So in this experiment, we will do reactions that involve solubilities. So you're going to mix magnesium nitrate with sodium hydroxide. So let's take a look where magnesium is in the periodic table. Magnesium is right here. It's a group 2 element. Then calcium nitrate with sodium hydroxide. Calcium is here, group 2, right beneath magnesium. Strontium is going to be below that, and then barium is right here. So we're basically testing the solubilities of these compounds as you go down the group in the periodic table. And then lastly, we have lead, which is situated sort of all the way down here in the periodic table, okay, one of the metals. So as an example, remember from your solubility table that all nitrates are soluble. So this is essentially in water, magnesium ion and nitrate ion. So we're testing to see the precipitate of magnesium hydroxide. Will you get a precipitate in the first place? Is that precipitate robust? Is that precipitate not so robust and small? Or, like I said before, is there even a precipitate in the first place? So as we go down the periodic table, we're measuring to see how good or how well the precipitate is, not just for the hydroxides, so magnesium hydroxide, calcium hydroxide, strontium hydroxide, but the chlorides, magnesium chloride, calcium chloride, strontium chloride, barium chlorides, the bromides, iodides, sulfates, carbonates, and then finally the chromates. So let's begin with our first set of reactions. We're going to react sodium hydroxide, so this is sodium ion and hydroxide ion, with all of these nitrates. So I already have everything put in, 1 ml. So this would be my magnesium nitrate, calcium, strontium, barium, and lead. So we're going to do 1 ml of sodium hydroxide down this row, and we will write our observations. So our first one is sodium hydroxide with magnesium nitrate. Okay, so let's do our little tap, tap, tap motion. So we definitely see a precipitate. The purpose of this lab is to really make an assessment on how well the precipitate is. So I'm going to say that this precipitate is, well, it's white and translucent, and it seems to be medium amount, okay? Not small, not large. Again, this is subjective, okay, for those of you that are doing the lab. So I'm going to say maybe slight, it's very cloudy actually. So let's just call it a cloudy, translucent precipitate. So, and white also. All right, now let's do sodium hydroxide and calcium nitrate. All right, so much more robust precipitate than the magnesium hydroxide. Okay, yeah, definitely we have a little bit more intense white color, and we'll say a white precipitate. Okay, also cloudy, but I feel like it's a little bit more than the magnesium. Remember, magnesium and calcium are in the same group in the periodic table. Okay, this is also cloudy, but it's a lot more than the magnesium here. Okay, so calcium hydroxide precipitates probably a lot better than magnesium hydroxide. All right, strontium is next. Another white cloudy precipitate. So we'll just call it a white cloudy precipitate, pretty translucent, not as robust as before, so that's what we'll go with there. Not as robust compared to the calcium and the magnesium hydroxides. All right, barium nitrate, sodium hydroxide. How well are these hydroxides going? Kind of the same situation, a very weak precipitate, okay, very particulate, there but not really there, so you got to look really hard. So white cloudy precipitate. All of these are hydroxides. Some are more soluble than others, some are more insoluble than others. All right, finally in our hydroxide series, lead nitrate, sodium hydroxide. Let's see how lead 2 hydroxide is. Oh yeah, okay, you can see that. Definitely a sharp white precipitate, very milky. Okay, robust I can call it. Definitely it will settle down, and it's very white, cloudy precipitate, PPT. All right, we finished our first row. Now we're going to test the chlorides. All right, so now let's test the chlorides. I got my magnesium, calcium, strontium, barium, and my lead nitrates. This is the chlorides by putting in some sodium chloride. So let's do our first one here. Don't see much of anything. I'm going to say no reaction. Everything is soluble. All right, calcium nitrate with sodium chloride. This should give us calcium chloride. Like before, just like magnesium chloride, calcium chloride is, yeah, nothing's happening, no reaction. Looks to me like, just looking at these two, that the chlorides going down, magnesium chloride, calcium chloride, are not soluble. That is to say, they will not precipitate. Okay, let's try soluble. Looks like all these chlorides are soluble so far as we go down group 2. So no reaction here. All right, barium nitrate with sodium chloride. Let's see how barium chloride will be. Going down group 2, the alkaline earth metals, I don't think the chlorides are very insoluble. In other words, the chlorides are very soluble in water. Okay, no reaction, no precipitate. All right, let's try lead, finally. Lead. Okay, another robust precipitate. All right. So lead 2 chloride is a very sharp, very white, cloudy precipitate. I'm going to write very white, robust precipitate because that's what I see. It was almost instantaneous. All right, so these are the chlorides, lead chloride, lead 2 chloride, lead 2 hydroxide, very insoluble. And chlorides do not seem to be very... All right, magnesium nitrate with sodium bromide. And don't see much of anything here. Okay, always do your mixing. And no precipitate, no reaction. Sodium bromide, calcium nitrate. Same situation. Looks to me like we have no reaction, no precipitate. All right, so doing calcium nitrate and sodium bromide, we have no reaction. Okay, doing that mixing there, no precipitate, no reaction. Sodium bromide and strontium nitrate. Seems like there is no precipitate going on here. And I'm going to write no precipitate, no reaction. So definitely looks like the bromides are soluble. Let's try sodium bromide with barium nitrate. You always want to look very closely because sometimes the precipitate may be very, very small. But when I'm doing my tapping, I don't see anything floating. And I don't see a precipitate. It looks as clear as water. So we're going to say no precipitate, no reaction. Okay, finally, lead nitrate with sodium bromide. This will be lead 2 bromide. And we definitely have a reaction going on here. Okay. Call it a white milky precipitate. Looks like milk to me. Again, your observations may be different. So white milky precipitate, lead 2 bromide, white milky precipitate. All right, let's test the iodides now. Sodium iodide with magnesium nitrate. So here's my magnesium nitrate. And let's see what we get here. We get a very strong precipitate. Bright yellow precipitate, okay, very particulate. It's a very bright yellow precipitate. clumpy too. It's starting to clump. All right, calcium nitrate and sodium iodide. So here's my calcium nitrate, test tube 2. These are qualitative. I see no reaction here. Okay, don't see much of a precipitate. All right, next up down the group 2A, sodium iodide, strontium nitrate. Don't see any reaction, no precipitate, no reaction. All right, barium at the bottom of group 2, nitrate with sodium iodide. I see no precipitate, no reaction. All right, finally lead. Lead 2 nitrate with sodium iodide. And looks to me, I don't see much of a reaction here. You want to look closely. Sometimes the precipitate can be kind of small, so definitely look. And I don't see much of a reaction here. No precipitate, no reaction. All right. Continuing on, let's do magnesium nitrate and sodium sulfate. So here I got my magnesium nitrate, tube number 1. Mixing it. And do not see any precipitate. Looks like everything is soluble, no reaction, no precipitate. All right, sodium sulfate, calcium nitrate. All right, like before, don't see much of a precipitate, so no reaction, no precipitate. Everything is soluble. Sodium sulfate and strontium nitrate. This is definitely a precipitate. It's cloudy, powdery, cloudy precipitate. If you compare those, you can see there's definitely a precipitate here. So I'm going to call that a white, maybe powdery precipitate. Soluble, soluble. Strontium sulfate seems to be insoluble. Again, check your solubility table. This is an important tool to have, your solubility table for this experiment. Barium nitrate and sodium sulfate. I already know this will be barium sulfate. So there is the milky white precipitate, insoluble barium sulfate. Okay, that's barium sulfate. Sodium sulfate and lead 2 nitrate, our last one in the row. Another robust, almost instantaneous precipitate. And we have a very white, let's do our tapping here. As before, milky white precipitate. Same thing with this guy here, milky white precipitate. Sodium carbonate and magnesium nitrate. We're testing the carbonates now as we go down group 2 of the alkaline earth metals. Okay, something has occurred here. We definitely see a cloudy precipitate, not as great as the other ones. So it's not instantaneous, but we do see a cloudy precipitate. Cloudy white precipitate, I'm going to say. Sodium carbonate and calcium nitrate. Okay. A more robust precipitate. So milky white precipitate, definitely a lot greater in substance and quantity than the previous reaction. Okay, if you want to compare, look at this one. Okay, kind of transparent white. This is very white. So something's going on with the carbonates. So I'm going to call it a very white precipitate, comparing it to this guy. Okay, milky also you can say. Sodium carbonate and strontium nitrate. Another pretty robust precipitate. So these carbonates seems like they like to precipitate, they like to be insoluble. And then we're going to call this a milky white precipitate. Barium nitrate with sodium carbonate. All right, we do see a precipitate form. It's white in color. So something has definitely come out of solution, and we're going to call this a milky white precipitate as before. Right? So definitely we have a lot of carbonates. Carbonates like to form precipitate. And finally, sodium carbonate and lead 2 nitrate, the leads. And again, a very cloudy precipitate. Okay, this is something that seems, in my opinion, very robust. Okay, so it's almost instantaneous. I'm going to call it very robust white precipitate. You can actually see the colors, the whiteness if you can. Look at how white something is. This is very, very white. So calling it a robust white precipitate. All right, our final one here are chromates. This is sodium chromate, and let's let it react down the road. All right, chromates, sodium chromate with magnesium nitrate. Magnesium nitrate is test tube 1 here. And don't see much of a reaction here. Don't see much of anything, no precipitate, no reaction. Sodium chromate with calcium nitrate. Oh yes, we do see a precipitate here. So milky white precipitate. Milky white precipitate. All right, chromate and strontium nitrate. Okay, another big precipitate. These things do not want to stay in water, it appears to me. Another milky white precipitate. Sodium chromate, barium nitrate. You know, a lot of powdery, flaky, sticks to the side of the tube type of precipitate. So I'm going to call it a powdery, maybe flaky precipitate. Milky white also in color. We'll call it flaky. It likes to stick to the side of the tube. Flaky, white, milk precipitate. And then sodium chromate, lead 2 nitrate. Another precipitate on our hands. This looks to be like very fluffy. It almost looks like a powder. Looks like cotton to me. That's just me. So I'm going to say white, cotton-like fluffy precipitate. So the chromates definitely are giving us precipitates, except for magnesium. Cotton, fluffy, like white precipitate.